Math 1314, section IC1, spring 2022, Tyler Junior College, section 5.5, point slope form, parallel and perpendicular lines, video 1, point slope form. In the previous section, we learned about slope-intercept form. If the slope of a line is m and the y-intercept is 0, b, then the equation of the line in slope-intercept form, SIF for short, is y equals mx plus b. Now, most people, when they think slope-intercept form, they think this, y equals mx plus b, and there's nothing wrong with thinking that. But really, on its own, it doesn't capture everything. So to me, slope-intercept form is this entire statement followed by the equation y equals mx plus b. But if all you remember is y equals mx plus b, you're going to be okay as long as you remember that m is the slope and b is the y coordinate of the y-intercept. This is a very convenient form to have because it allows us to instantly know the slope and y-intercept of a line. And you may recall from the previous homework, from the previous section, that if you know the slope of a line and the y-intercept, that's enough information to actually draw the graph. However, there's a flaw to slope-intercept form. It is not the best form to build an equation, as we need two very specific pieces of information to start with. Namely, we need the slope and the y-intercept. Every line has a unique slope. If the slope exists, vertical line is the exception, and a unique y-intercept. If the y-intercept exists, vertical line is an exception, unless the vertical line is right on the y-axis, in which case every point is technically a y-intercept. But my point is, if you have something besides the slope and the y-intercept, then slope-intercept form is not really the best place to start. This raises the following questions. A, can we build the equation of a line if we know its slope and a point that is not the y-intercept? Well, we've already done that, but we really haven't done it. When I say build an equation, I mean take the information you're given, stick it into the equation and say, there's my equation. When we did, let's be getting ahead of myself. Anyway, we'll revisit that in a second. B, can we build the equation of a line if we know 2 points on the line? Well, of course, the answer to both of these is yes. In the previous section, when we had the slope and a point that was not the y-intercept, we crammed everything into y equals mx plus b, and then we solved for b. That will work, but the problem is when you insert the values in to slope-intercept form, that doesn't give you the equation of the line. Just a real quick example. For example, let's say we had a slope of 4 and the point was 2, -5. Then when we put all these values into slope-intercept form, y is -5, m is 4, x is 2 plus b, this isn't the equation of the line in slope-intercept form. This is an equation that we can solve to get b, and if you think about it, you get b equals -13. And then once you got b, then you could say that the slope-intercept form is y equals 4x minus 13. So when we put what we know into slope-intercept form, but we don't have the slope and the y-intercept, that we don't have the equation of the line the minute we plug everything in. So I'd like an equation of a line that says, give me the information you have and I will instantly give you back the equation of the line. That doesn't happen in this example, so let's get rid of that. All right, so what can we do? Well, although this will work, there's a more direct equation that takes in the slope and the given point. Really, I should say a given point. So let's make that say a given point, and immediately gives us an equation, albeit it's not in slope-intercept form. Gee, I wonder what you would call a form that will take in a point, any old point, and the slope, and give you an equation. To derive this form, consider the line whose slope is m and contains the point x1 comma y1. Note, this is a specific yet unknown point. Let's kind of draw a real quick picture of this to see what it would look like. Okay, now it's kind of hard to draw this picture since we don't have anything specific. All we've got is some point that we don't know, and we are currently calling x1 comma y1. So let's just put it right here, because we don't have any good reason to put it anywhere else, and some random slope that we don't know. So we'll just draw a line going through this point, and we'll say that its slope is m. Well, how are we going to build an equation when all we got is one point and a slope? Well, let's think about it for a second. We want to know what every point on this line has to do. So we're going to take a generic point x comma y on this line and ask what must be true. Again, keep in mind that the x1 comma y1 is a specific point. And now we want to ask the question, one second, folks. Now we want to ask the question, if we take any generic point, I want to do something here. I'm going to throw it over here for a second. But if we take any generic point x comma y, what has to happen in order for it to be on the line? So let's grab all this and we'll move it here. Like if it's there, or if the point's here, or if the point's here, no matter where we put this point, what has to be true? Well, we're going to answer that question in the next slide. Let's draw the picture again. We have a specific fixed point, x1 comma y1. So we would be given numbers there. For example, that point looks like it could be, I don't know, 5 comma 3. And we would be told a specific slope. Excuse me. Didn't think you'd want to hear me sneeze. And we're given a specific slope. For example, we could be told that the slope is 1/3. Then how would a generic point x comma y get to be on that line? Well, the answer is really simple. The slope between the 2 points has to be m. So all we have to do really is set up the slope formula and apply it to the 2 points in the picture. Now, notice the generic point is not labeled with x2 and y2 with a subscript of 2. When you put a subscript on a variable, you're often saying this is a specific value that we don't know. And I don't want to do that here because I want that xy to be a floating point, if you will. But think of it as the second point. So what's the formula for slope? Well, in the numerator, we do the second y minus the first y. And in the denominator, we do the second x minus the first x. I'm going to do two things to make this equation look a little bit better. Number one, I'm going to put the equal m on the right side. There's absolutely nothing wrong with putting it on the left side, but equality, the equal sign, is symmetric, which basically means if you've got one thing equal to another, you can say the same thing by simply switching the sides of the equal sign. Now, this isn't the same as subtracting m from both sides. I'm just looking at the inequality as if I'm standing on the other side of the screen and reading it from the m side towards the fraction side. And the other thing I want to do is get rid of that fraction, because dang it, it's a fraction and I don't want it there. Well, we know how to get rid of fractions. We can multiply both sides by the denominator. In this case, the denominator is x minus x1. Put both things in black before I switch it back to red. And if we do that, then it'll cancel the denominator on the left side, and it'll leave us, and I'll just keep it in red now, y minus y1 equals m times x minus x1. And take a look at this equation for a second. I'm going to put it in a black box. Take a look at that equation. It contains a generic x and a generic y, the ones without the subscripts. And it also contains the slope m, and it contains the x and y coordinates of the specific point x1, y1. In other words, if I'm given a number here, and a number here, then I could just substitute them here, here, and here. And that'll give me an equation that contains the information that I was given and represents this line. Get rid of those highlights. And that equation in the black box is what's called point slope form. Point slope form goes like this. If a line contains the point x1, y1 and has slope m, then the equation of the line in point slope form, PSF for short, is y minus y1 equals m times x minus x1. That merits having a red box put around it. But keep in mind the information that point slope form requires, almost as if this is a recipe calling for two ingredients, a point and the slope. By contrast, slope-intercept form requires the slope, there's only one per line, the y-intercept, there's only one per line. Point slope form says, yeah, I need the slope, but any old point will do. Just stick it in this equation and we can go to town on it. Now, of course, we could always take that answer and turn it into slope-intercept form, as you'll see here in a moment. But this is the other form, point slope form. I didn't type this earlier. I'm going to type it now. Point slope form. Point slope form is the, in my opinion, standard way to build the equation of a line. If we want the equation in slope-intercept form, just solve point slope form for y. So think of it this way. Slope-intercept form y equals mx plus b is a good ending point for a line because it's unique for every line. Every line has a unique slope and a unique y-intercept, except vertical lines, and therefore has a unique slope-intercept form. So it's a unique ending. But the beginning of the equation is a little bit more flexible, point slope form, because although every line has a unique slope, every line has an infinite number of points. So point slope form is capable of taking in a much wider array of information, namely the slope, but any old point you want, and get us to slope-intercept form, which again is unique for any given line. All right, let's take a look at a few examples. Find the equation of the line that contains the point -6, 7 and has slope m equals 4/3. Don't let the fraction intimidate you. This is much easier than it may seem. The fact that we were given a point and a slope is a dead giveaway that we should start with point slope form. Now, you don't have to write point slope form in its generic form every time you use it, but it helps. Y minus y1 equals m times x minus x1. And I recommend literally labeling m is 4/3, x1, that's the x we were given, and y1, the y that we were given, before substituting them into slope-intercept form. Now I'm going to write point slope form. Now I'm going to write point slope form, but I'm going to take out every letter that's going to be replaced. So the y1, the m, and the x1. If you'll notice, or focus on this for a second, the thing in the green box is what I call, I'm sorry, folks, my nose is just running off my face. The thing in the green box is what I call the structure of point slope form. In other words, you can set that up and there are 3 spaces in which to drop the values after the subtraction sign, after the minus, in front of the parentheses, and after the second subtraction sign. So all we have to do now is put in the values that we were given. The value of y1 was 7. I wanted that to be blue. The value of y1 was 7. The value of the slope is 4/3. And the value of x1 is -6. Now, if a question asks you what is point slope form, this is an acceptable answer, almost. There's only one thing in this answer that you would be expected to clean up if the homework asked you to enter the equation in point slope form. Do you know what it is? It's the double negative. Although a double negative is not technically wrong, it is considered unfinished. So if you were to ask to write the equation in point slope form, this would be your better answer. y minus 7 equals 4/3 times x plus 6. Notice this equation still contains the slope, and it still contains remnants of the original ordered pair, -6, 7. But just like when you put the coordinates of the center of a circle into the equation of the circle, the signs appear to change when you insert the coordinates of the point into point slope form. Now, is this a good stopping point? Well, that depends upon the question. If the question were to ask you to simply write the equation in point slope form, mission accomplished. But, and this is more common than not, in a homework question, you'll often be asked to then convert to slope-intercept form. And remember, slope-intercept form is the form y equals mx plus b. So if I wanted to convert this to slope-intercept form, I would simply have to distribute to get rid of the parentheses and then isolate the y, which in this case would mean adding 7 to both sides. So let's get this in slope-intercept form by first distributing the 4/3. Now, the fact that it's a fraction may worry you a little bit. Don't worry about it here because, number one, putting it in front of the x is not a big deal. Ooh, I wrote a fraction in front of the x plus, but figuring out 4/3 times 6 might still not be in your comfort zone, needs to be there because this one's easy. Multiplying fractions is the easiest thing to do, across the top, across the bottom. But 6 isn't a fraction. Okay, put the 6 over 1 and now it's a fraction. You could multiply across the top to get 24 and across the bottom to get 3. Or you could reduce first. This 3 will reduce into that 6 and leave behind a 2. That will leave 4 times 2 on top, which is 8. And on the bottom, we're just left with, well, technically there's a 1 left over with a 3. 1 times 1 on the bottom, which of course is 1. And of course, 8 over 1 is just 8. And now to finish getting it in slope-intercept form, we could just add 7 to both sides. And that would give us y equals 4/3 x plus 15. Do you have to put it in slope-intercept form? No. But if the homework says, give me point slope form, now convert it to slope-intercept form, this is what you would be expected to do. Let's take a look at another, because I'd be lying if I said all of them went that smoothly. And when I say smoothly, I mean when I multiplied the slope times 6, the fraction 4/3 times 6, it came out to be a whole number. Not always the case. Find the equation of the line that contains the point -6, 7 and has slope m equals -3/5. Well, this is going to set up the same way. Let's start with point slope form, y minus y1 equals m times x minus x1. And as usual, you're always welcome and encouraged to pause the video before I go any further in a question to see if you can do it without following my lead. And then you can always resume the video and see if we get the same answer. All right, let's put everything into the equation. X1 is -6, Y1 is 7, M is -3/5. Let's write point slope form without the Y1, without the M, and without the X1. And then substitute the values. Y1 was 7, M was -3/5, X1, that 1 looks like a comma back here. I want to fix that. There we go. X1 is -6. Well, just like before, we got the double negative right here. So if we were to write the answer in point slope form, we would be expected to clean that up. Our final equation in point slope form is y minus 7 equals -3/5 times x plus 6. Again, whether or not you stop here depends on whether or not the instructions to a problem ask you to write the equation in point slope form. This one is in point slope form, so if that were the instructions, then we would be done. But I do want to convert this to slope-intercept form. Now, convert to slope-intercept form. And again, not all problems will ask you to do this, but it is a good skill to have in your skill set. Converting point slope form to slope-intercept form always involves fixing the same two problems. Number one, slope-intercept form doesn't have parentheses, so we'll distribute. Number two, slope-intercept form has y by itself, so we'll have to isolate the y after we've gotten rid of the parentheses. On this one, when we distribute the -3/5, we'll get y minus 7 on the left. That didn't change. Equals -3/5 x. Great. Now we got to do -3/5 times +6. Let's just figure that out down here. -3/5 times +6. Well, we can treat this just like we treated the one back here on the right when we figured out 4/3 times 6. We can put the 6 over 1, but unlike the previous one, there is no canceling here. No factor in the denominator will reduce with any factor in the numerator. Our only recourse here is to multiply across the top. Well, first off, negative times positive is negative. And across the top, 3 times 6 is 18. And along the bottom, 5 times 1 is 5. So that wasn't too bad. Let's put that in a cloud. This is kind of a thought. That wasn't too bad. We got -18/5. But we're not out of the woods yet because now we have to add 7. Because remember, if we want slope-intercept form, we have to isolate the y. The -7 is preventing that. So add 7 to both sides and we get y equals -3/5 x. And now we need the answer to this addition problem. -18/5 plus 7. Well, let's take it down here for a second. -18/5 plus 7. What is the rule? Let's put the plus 7 next to it. What is the rule for adding fractions? The rule is get a common denominator to add the numerators. The -18's denominator is 5. The 7 has an implied denominator of 1, but that's the best denominator to have because I can easily turn it into anything I want. I want the 7 over 1 to be something over 5. So I'm going to multiply both sides of the second fraction by 5, and that will give us -18/5 plus 35 over 5. And now that I have a common denominator of 5, I can just combine -18 and +35. I believe that is +17. That's the answer to -8/5 plus 7. And so our y-intercept ends up being +17/5. And that is our slope-intercept form. Things get a little bit crazy when the slope is a fraction and it doesn't play nice when you multiply, as opposed to this one where it played very nice. I multiplied 4/3 times 6 and I got just 8. Here, -3/5 times 6, I got -18/5 and then had to add 7 to it. It's manageable. I believe we have one more example, and that's the end of this video. Seems to have gone on longer than I wanted it to. Why is my name up there? Go away, name. You bother me. Thank you. All right, find the equation of the line that contains the points 4, 1 and -4, 3. Why is this problem different? Why is it different from this one? And why is it different from this one? Answer: we weren't given a slope. We were given 2 points. Well, point-slope form needs a point and a slope. We have a point and another point. Does that mean there is a point-point form? Actually, there is, but we don't need it. Why do we not need a point-point form? Because we got everything we need for point-slope form. We have 2 points, but we don't have a slope yet. So here's what you need to know about finding the equation of a line when you are given 2 points to begin with. First, use the slope formula to find the slope. Okay, I can do that. I've got a recipe that says give me 2 points and I can make a slope out of it. Slope formula is m equals y2 minus y1 over x2 minus x1. We get those from 2 ordered pairs, and we have 2 ordered pairs. x1 is 4, y1 is 1, x2 is -4, y2 is 3. Let's put all those in everywhere they belong. y2 is 3, second y is 3, first y is 1, second x is -4, first x is 4. And what does this give us? Well, on the top, 3 minus 1 is 2, and on the bottom, -4 minus 4 is -8. We get 2 over -8. which first off is negative, so I'll put the negative in front of the fraction. And secondly, 2 over 8 reduces to 1/4. Oh, goody, a fraction. Well, guess what? Slopes, by their very definition, are fractions. They normally turn out to be non-integers rather than integers. All right, so what did we just find? We just found the slope. Why did we find the slope? Because we want to use point slope form. Now we have a point, we have 2 of them to choose from, and we have a slope, -1/4. So now we're going to use point slope form. Now, we do have a choice to make. We have 2 points, and either one of them will do. So I'm going to put using either point, but the temptation is to use the one that I've already labeled 1s, because my form right here has x1 and y1. But it was completely arbitrary for me to call the first point 1, x1, y1, and the second point x2, y2. I could have very easily have called this point x1, y1, even though it's written second. Shoot, if I had moved that point over here and vice versa, it would have been listed first, and it would have been x1, y1, and we would have gotten the same slope. If you don't believe me, reverse the order of the points, recalculate the slope, and realize that we get the same thing. The negative would just show up on top instead of bottom. All right, so we can use either point, but we'll use the one that's already labeled x1, y1. I would have chosen that one anyway because it has fewer negative signs. Our point slope form is y minus y1 equals m times x minus x1. Using the point labeled x1, y1, we get y minus 1 equals -1/4 x minus 4. Now, at this point, we technically have the equation of the line. And if a homework problem does not say convert it to slope-intercept form, you are justified in stopping here. It asks for an equation. You want an equation, you got an equation. Y minus 1 equals -1/4 times x minus 4. But I'm telling you right now, many of these problems will conclude by saying, finally, convert to slope-intercept form, which isn't nearly as hard as it may seem, even though there's a fraction in there. Because when we distribute this, the multiplication is going to make the fraction disappear. We get y minus 1 on the left because nothing's changing. -1/4 times x is -1/4 x, not a whole lot to look at there. But on the second end of the distribution, we have -1/4 times -4. Give me 1 second to move everything up some. All right, so we were about to multiply -1/4 times -4. Let's draw that just a little bit better. -1/4 times -4. Well, first off, negative times negative is positive. Secondly, the 4's cancel. So the only thing I'm left with is a 1, more specifically a +1. So that wasn't too bad. I'm not in slope-intercept form yet because I have to solve for y, but adding 1 to both sides will accomplish that, because that will get rid of the -1, leaving the y by itself on the left of the equal sign. And on the right side, we have -1/4 x. And of course, 1 and 1 is 2. Our slope-intercept form is y equals -1/4 x plus 2. So to summarize, there's 2 key things you need to know in this section. Number 1, point slope form will write the equation of a line with just a point and a slope. It's in this top pink box here. It's in the left green box here. It's in the top green box here. That's just the form. Secondly, all point slope forms can be turned into slope-intercept form. And I guess 3 things. Thirdly, if you're given 2 points and you want an equation, make a slope, use point slope form, and then to finish it off, convert it to slope-intercept form. So let's stop the recording there. So let's try it again.